one film. Okay. Yeah. So online. Online. Oh, cool. Cool. Sang không biết việc phát triển có cái câu chuyện về bài hình như thế. Okay. Morning, everyone. We'll start on time, and if you take your breakfast, please just enjoy it. No problem. So, the first, I want to provide a recap for last week. The first is about me. I say something about myself and in this industry, and hope it helps a bit for you. And second, we learn how to actually, we try to learn anything with internet, right? So assume you don't know anything about 5G, you don't know anything about QoS, but we still can learn something by internet, right? So I do the same job in last year to 2024. And that time I used only use internet. But this year is different because we got the AI from cloud to the ground. Because DeepSeek, it pushed everybody to provide a powerful, more powerful and more cheap AI. So we can learn by internet, powered by AI tools. Okay, so we do this comparison in last week, and we get a conclude by your decision, right? There's a Claude, Brook, and the DeepSeek is the first reading, the best tool to learning anything, but we are based on 5G QoS material. And next one, we learned the first lesson of 5G end-to-end QoS based on the material in internet. Yeah, so I hope you can use the AI tools by yourself to deep dive and learning more. Full screen.
Yeah, in the wrong screen.
I share the screen.
But it's wrong screen.
Okay.
But
You want to record this one? I finish.
yeah, you can not be wrong.
No, I need another slide, but it's okay.
Oh. Oh, sorry.
Please check. Yeah, I think you got it. Thank you, Ian. So any question about last week? I hope you already prepare your homework about this lecture. I think the same. Get a small stance and share screen. Okay. Today we will provide more detail about the end-to-end corporate. Actually, that's what we will meet in our job, maybe in your future. And I think that's more valuable to you because in my experience, there's a few guys getting fewer. They don't want to analyze by themselves. You know, about 20 years ago, the Wireshark actually is a real. The older name, the previous name is a real. And at that time, the engineer, they like to use Etherreal to analyze the protocol, internet protocol by themselves. But I don't know what happened. Maybe people getting lazy or they don't like to look at the protocol. So, you know, even Ericsson, the engineer, very good engineer in Ericsson or Nokia in Taiwan, I met. They are not very good protocol expert, you know. So I think the lesson for you guys, it should be very helpful. So today, I hope you can enjoy. Okay, so we will go more detail about end-to-end QoS corporate. Okay. Okay. Again, that's the resource I have. Also, you have. The first, we use internet to check the 5G end-to-end QoS. You can get something YouTube, and I bought a book, and we can find a very good resource in WeChat if you can read in the Chinese, and a lot of resource in website, and of course IEEE. I guess you guys you have account to access IEEE, right? Please use it because I don't have the access right. You know my background. My background is not in engineering. Actually, I'm from physics and oceanography. Yeah, but I have a 25 experience in this industry. So please use it and on-job training. And I ITU-T, actually the original materials from ITU-T, they're talking about very classic about original definition in telecom, QoS, QoE, and SLA, quality of service, quality of user experience, service level agreement. And here is the number of the document. Please search by yourself. Actually, you are very lucky because now almost everything is free. You know, in my age, your age, everything should be paid. You cannot get free by internet. You have to write down a paper to apply to my boss, say, I need to buy this one. And explain a lot why I need it, because it help my job to understand the QoS. And then you waiting for 2 weeks, and then you will get the paper hard copy, 2 weeks, and then it will cost about 200 or 400,000, 4,000 NT dollars, 4,000 for about 60 page only. So I think we are so lucky because we can get almost everything free, and they are very valuable. And the second, I reordered our resource. So first, we have to learn what is 5G network architecture, QoS architecture, and QoS flow, and how many QoS type and the parameters, and the 5QI characteristic. What is 5QI? 5G QoS identifier, and something learning from my job. That's our log. Okay. We will take some time on this architecture. Okay. We have mobile insert the USIM. So we got the IMSI inside the mobile, right? And there are two. One is emulator, one is real genealogy. And we have the interface connect to AMF and the UPF. AMF is for control plane. UPF is for user plane. So I have a slight question here. Have you any idea about control plane and the user plane? Because the term is used in telecommunication, so I don't know, is it so common to you guys? Control plane and user plane. Do you know that? So anyone want to explain what is control plane? What is user plane?
User plan is for internet.
For internet. And what is control plane?
I cannot explain that.
Okay, good. Thank you. But user plane is for internet. Actually, it's not so correctly. Later, I will explain to you. Anybody want to explain what is control plane? What's user plane? It's very basic, just like ABC in telecom. If you learn something about telecom, it's cool. But what is control data? No. Please continue. What is control data? Tell him what to do. Tell the user what to do. And what is the user plane? Yeah, more close. So I will try to, no, I look at something, someone would want to raise him. You want to add more? Okay, so I will use my way to explain it. The control plane just like when you use your mobile or your mobile, you try to dial somebody, okay? Or even basically when you power on your mobile, but you don't need to do everything. the mobile basically will searching for the best GNODB or base station and to access and to do the registration automatically. And then you will see, my mobile is ready. Why? Because you see the signal bar or 5 stone or Taiwan mobile is ready. So you try to dial it. For example, you dial your girlfriend or boyfriend, and then you send, and then you see turn, 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 right? Until now, everything on the background is control plane because the mobile is very busy. He tried to send out your B party number and then send to the switch, and the switch try to looking for who is the number and then try to paging. The paging is sending is like you turn, turn, turn. So when your boyfriend, girlfriend pick up his phone, her phone, then you connect it together. Then you say, hey, hey, where are you? Then your voice is user data. It goes through the user plane. Before that, everything is control plane. So control plane is busy, but almost the network and your mobile do it in the background. So you don't know the detail, but they do everything for you. So you just say, hey, you just send a picture and you just say hello to your friend. Let's go through the user plane, the user data. And when you disconnect, then everything go to the idle. And your background continue. You go to different location. You will do the tracking area update. Why? Because the mobile need to page you immediately if your girlfriend or your boyfriend want to looking for you. Also, if you are talking about OTT, OTT means the WeChat or Facebook or IG. You will get a notification immediately or show messaging. Then you do the location update frequently, so the network know how to paging you immediately. Okay, so I go to detail, right? But it's okay. Now we have idea about control plane. So in 5G, every control plane goes through AMF. And when you get connected, you will send your data go through the UPF. Okay, just remember that. Okay. Yes, yeah.
We can ideas like control plan. It also controls when we have, for example, I'm buying a data package from someone.
Yeah.
I have options whether it's unlimited package to top up or it will be limited package, but like 1 giga.
Yeah.
And the control plan will check whether I still have quota access to the internet. That's for control plan. But for maybe I can explain for the user plan. It's like it's maintains, for example, I'm streaming the data, the video data, it's flowing through the data user plan. Is it correct? Is that correct?
Your last statement, please again.
Like for user plan, it contains purely the data only. We don't have any control on the user plan. For example, I'm streaming the YouTube, so the video data, the video will be sent to the user plan.
Okay, the last statement is about user YouTube, right?
Yeah, or maybe FTP, I'm sending data to YouTube. It will go through the user plan.
Okay, okay. Case by case, actually, if you are talking about YouTube, it's more complicated because actually you send the request. Actually, it's everything already here. Even you cannot get the. For example, you have problem about the network. You get a very narrow bandwidth, right? But you still can browse the YouTube like content, but you cannot look at the detail. When you try to click on, then you will see your mobile just looking for, right? But actually, you do everything is already here. But you have a good example to everybody. Thank you. When you access here, actually on the background to the HSS, you will check your allowance just like QoS. or the how many quota you can continue to use. It goes through the control plane to check. Yeah, actually, it's thank you. So remember, in our end-to-end, what is end-to-end? Because our title is end-to-end. Actually, in 5G, the end-to-end definition is very simple. One end is user UE, another end is here. So everything here, from here to here, is end-to-end. It's very simple, end-to-end. From UE to here, and N6. So I will call it end-to-end. So that's why I provide two logs to you. One log is based on here. I call it UE log. So you can see the RC, NAS, and the user plane data. And another one is based on the 5G. So you can see the N2, N3, the log. So that is end-to-end log. But actually, we didn't capture here. So we just capture together N2 and the N3. N2, where is N2? N3. Here's N2. Okay, so we have the N1, N2, and you can see the solid line and the dashed line. Okay, most textbook like to use solid line to express the control plane, and the dashed line to express the user plane. But some textbook use different. Yeah, but this we don't mind because and solid and the dash is two different meaning. Just remember that. And there's a special interface between two G node P. We call it XN. It's between them. It's SN. And after MF, they are very complicated. I don't think you can remember. Okay, so MF for control plane, and the UPF for user plane. And after UPF, it's just like a gateway. So you will connect to like internet. So not only internet is for user plane. Actually, everything you use like email, like FTP, like OTT, including Skype and IG and Facebook and X, all OTT is user plane. Okay, so please take a few minutes to remember this important architecture. And because right now we have tested with Stroma Telecom, because they want to purchase our 5G emulator. So they are using the real mobile to make a lot of test cases around 4G, 5G handover or EPS fallback. Do you guys know what is EPS fallback? This is a new item for right now. EPS fallback. Okay, when we're talking about EPS fallback, we have very similar. It's CS fallback. And I will tell a little bit history. When you are using the 4G and the 3G, that's around 2014, around. And 3G, of course, is my age. It's a long time, around to this 4G, 3G. 3G era, the mobile data is very expensive. So everybody just using the 3G to very short, like when to check the website very shortly. We cannot take a long time on the internet. Otherwise, you will get an expensive bill. But 3G have very good voice quality. So 3G, you can see most is used for voice and limited internet. The 4G at the beginning, they are most used for internet. So what happened? If you stay in 4G, you enjoy the broadband of internet. But what happened if you want to make a call? You cannot, because 4G at the beginning, there's no voltage. LTE. Voice over LTE. That's just happened. Even right now, the voice over LTE just happened right now, around this year. So in this year, there's no voice over LTE. They are most used for internet. So in 4G, you try to make a voice call, you need to use the CS4 back. Circuit switch fallback. That means your mobile have to downgrade to 3G and to get your voice service. And when you finish your call, your mobile will automatically back to 4G to stay in 4G to enjoy your wideband internet. So it happened right now. The EPS is like this way. We call the LTE, the core network is EPS. So in 5G right now, the VONI is not popular. I believe maybe your mobile, even you are using 5G, but when you make call, your mobile will downgrade to 4G to connect to VoLTE, just like in 3G. After you finish your call, your mobile will connect back to 5G. So we call the procedure is EPS fallback. And EPS fallback, that's a very important interface is this one, N26. It's connect to MF to MME. So you can understand that MME, the role just like MF in 5G. Okay, they are peer. Also, here is peer. And E node B here is G node B. MF here is MME. And this is important interface. Okay, that's very important to control the EPS fallback. And EPS fallback is very like CS fallback. Okay, just remember that. Okay, so remember this important network architecture. Okay, now we will go more detail. So if you look at this one, it's about the protocol stack. So in future, if you try to go to the telecom industry, maybe you will research RD, then you need to coding for mobile or for general B or for 5G core network or for 6G. You have to understand the protocol stack. So maybe this is your first lesson. Okay. So here is the interface. UU, N2, N11, and the N4. Okay. So you can fall back to previous to identify the interface. Okay, and here is N3, and here is N11. Because they are important, so that's why in this one they draw together. Oh, sorry, that's N2. Okay, so this line is for control plane, not for user plane. So I will get here. The control plane is here. You go to the N2 and then go to the N11 to SMF4, section management function. Section management function, MF4 here. Yeah. So let's see the detail about the protocol. The first, the UU interface is air interface. And here is in your mobile. So your mobile basically have the antenna. Then that's baseband 5 and MAC and IRC and the PDCP and the RT. And then there's the two stack for NAS, non-straightened access, straightened, non-access straightened. MM is for handover. SM is for section management. So you can look like this one is for most for control plane, and this one is for data plane. Yeah, you can like this way. And here is G node B. G node B have two interfaces. One interface is including the antenna. so you can provide an OTA to mobile. And another interface is N2, that's by wireline. Because it's wideband, so the wireline actually is optical fiber. Optical fiber here is N2. And here is MFO. MF is very huge in Zhonghua Telecom because it connects to a lot of G0B. So it's very powerful, like Ericsson MFO or Nokia MFO. And here is SMFO. So here's another interface with SMFO. And here is N4 to UPF. So if we are talking about control plane and user plane, control plane and user plane, so the SMF is very important, it's between them. So if you are using a network emulator, all this interface inside is very important to you. Otherwise, you just know, oh, UE access to G0B and the N6 connect to iPerf, connect to FTP, connect to internet. That's all. You can do something in your lab. So let's see the more detail. The physical layer over the antenna to connect together. And here's peer-to-peer, MAC to MAC, ILC to ILC, PDCP to PDCP, RC to RC. And then the NAS is mapping here, NGAP, NGAP to NGAP, STTP, SDP, IP to IP. Here is the Ethernet. And then N11 is security, TLS to TLS. And here is FPCP, UDP. So very complicated. Every interface has every protocol stack to serve. And the most important is handset, not only communicate to G0B, also communicate to AMFO. Okay, look more detail. UU communicate with G0B with this peer protocol. And the UU have some like a registration or the data to internet. They want to get the service. So this NAS message is UU to AMF. You can see the color. And the section management is from UU to SMFO. So let's see the previous slide. The means the UU communicate with 3 network elements. Here, and here. Okay, so if you in your lab, you want to do the troubleshooting, and your call flow stop in somewhere, you need to check not only G0B, because one complete call, the UU communicate with G0B and the AMF and the SMF at the same time. Okay, just keep in mind. Okay, so this one is important for control plane. Any question? I hope you can understand right now, because it will help your homework and for your example. Sorry, I have a quiz about 10 or 12 question. Your final, yeah. So remember this protocol stack. Any question? Okay, let's keep moving. Another is for user plane. So you can see the handset here, physical, MAC, IOC, PDCP, the same, right? Like a control plane. Physical layer, MAC, IOC, PDCP. The four is the first four is same. But this is different. SDAP. Anybody remember what is SDAP? Last week, that's an important protocol stack. Only 5G have. 4G no. 5G have is SDAP. It's important for QoS. Okay, just remember that SDAP. So every user plane, like internet data, FTP, email, or WeChat, or one picture you want to send your girlfriend. Here, user data. It insert here, insert here, insert here, insert here, and then becoming carrier, send to the antenna. So GNOT-B received it, but GNOT-B didn't check your user data because you only check the SDAP, and SDAP will insert here GPRS tunnel protocol, GDPU. The user data will go to the UPF, and the user data is above the IP. So here is application. Actually, the application means everything: internet, FTP, email, gaming, or any OTT here. So the N3 connect to the cloud, the DN, and the IP to IP, the application to application. So this go to the previous, another here, just like here, N6. So you can see there's a cloud, there's a Skype, YouTube, IG here, and here you have some data, right? So it goes through this way. You, of course, your data sent to GNOT-B, but GNOT-B didn't check your user data. It just forward your user data to UPF. And of course, UPF to send through this one to the cloud, and the cloud have the application server to deal with your user data. So actually, it's end to end. Okay, so you have the picture, and you send to the Facebook, for example, and another people go to the Facebook to read your image, and then to give you a good, then the good will send a notification through here, through your mobile. So your mobile will get, oh, that's a good from your friend. Okay. Now we're back to our QoS. So there's 4 QoS: guaranteed bitrate, non-guaranteed bitrate, delay critical, guaranteed bitrate, and the refractive QoS. Okay, refractive QoS. So here is end to end. So now we have more feeling about this picture, right? Because we study the network architecture and every protocol stack. So we know here is UE, and here is GNOT-B, and here is UPF. So we will set up a big tunnel between UE and UPF. Then we call it PDU section. And because GNOT-B have 2 interfaces, right? One is the radio interface, another is wire. So you can see displayed here is the radio barrel and the GDP tunnel. We call it next generation user plane tunnel. Okay, so inside there are many different QoS flow, and especially radio barrel with 2 QoS flow, right? We studied there, but actually I checked with my friend in telecom. We cannot find one radio barrel with 2 QoS flow. I cannot find an example. This week I say yes, maybe real or not, but I share the screen to you guys. Do you try to understand it? I hope you understand it. In the line, I share you the VLAN example. That's a real call. And there are 3 radio barrel, 1, 2, 3. Each radio barrel with 1 QoS. Can you understand the line? I share you guys the important information. 1 VLAN. Okay, let me. Now you can check your mobile. I share it around maybe last week, or last Tuesday or Monday. Yeah. There's a VLAN. That's real call. So you can see there's a one ERP and another ERP. And the third ERP. And each one have one QoS, one QoS, one QoS. Just like this one. That's why I will show you. But this week I was wrong because I think the VONI maybe is a good example. One ERP included 3 QoS, but I was wrong. So please correct it. In VONI, 3 ERP with 3 QoS from. So we still cannot find this one. I don't know what is that. This one means one radio panel with 2 QoS. Okay, I think this one is important, but unfortunately, I cannot find a real example for that one. But ideally, because 3GPP show that, so that means it's possible one radio panel with 2 kind of QoS. Okay, just remember that and correct your mind. Okay, so we will show more. Okay, DRB here. DRB here. And this one is special. One DRB with 2 QoS. But as I mentioned, actually I cannot find a real example for you in my job. I thought maybe this one DRB with 3 in VOR. But actually I was wrong because Qualcomm, you know, the Qualcomm and the MediaTek in 5G, they are the peer. But in the 4G and 3G, Qualcomm is very advanced. But you know, the MediaTek actually getting very close to Qualcomm. So in 5G, I would say the number one have 2. Qualcomm and the MediaTek, they are in the same level in 5G. Okay, so we usually use Qualcomm as our 3GPP standard. So if you check your mobile phone based on Qualcomm chip, you will say, oh, this is something from 3GPP, just like a standard. Okay, so I was mentioned again, I didn't find this way in Qualcomm mobile. I just can find one DRB with 1 QoS, one DRB with 1 QoS is one. Yeah, but this is allowed in 3GPP. One DRB with 2 or more QoS flow. And this is important. Dedicated radio barrel is wrong. The correct is data radio barrel. Okay, remember. And this one is very good, but I will not repeat again because we explained it in last week, and you also can find it by yourself. This very good one. It's very detailed. And the call procedure, right? In order for PDU section default. Okay, what is default? That means even you didn't pay the special money to Chunghwa Telecom or Firestone, but when your mobile to power on, you get access. You have the right to use the default QoS, like internet, FTP or OTT. It's very basic service. It's default QoS. Bro. Okay. So now we will go to the very detailed. Okay. Because this is my job, so I enjoy the call flow. I call it the call flow. I enjoy the call flow very much. So I like to explain it more detail to you. Okay. So the first is the mobile and AN sometimes access network, radio access network. That means it's the G node B. Okay, G node B. And here is MF, and here is UPF, SMF, PCM, UPN, and EN. Here is more detail in 5G, but we can skip it right now in our lesson. Okay. So our PDU section establishment request is from UE sent to MF here. So in the background, MF will need to check the SMF. SMF will respond to MF, and then you will get a PDU session authentication. And then in the SMF, we'll check the PCF and the UDM policy and the section establishment modified. Until here, you will see the PDU section request to G-Node B and G-Node B to UE. So you can see from the UE side, you just send to, hey, I want to set up the PDU session. And the background in 5G is very busy. Just like Ian mentioned, the core network will check your allowance and how many money you can use for the service, something like that. They are very busy. And also, they want to check if you are really user or you are just like a hacker. You try to access to use their network by free. So the background is very busy for many reasons. Okay, and then actually here you just get okay. You can set up the PDU acceptor. You can see the request compared to acceptor here. Then your handset will get acceptor. Then you can continue moving to next. You get acceptor, right? So you can send your data, uplink data. You can get your downlink data. So just you mentioned, after here, you connect to YouTube to get your request to cloud, UPF to N6 to the cloud. And then you will get your download and you will get your streaming data from this one. And the background is still very busy because the AMF have something to change it. For example, if you go to different website, maybe you need a more broken data. So on the background, they will change something for you to make sure you can get the best QoS service. Yeah. So remember, UE to get a fewer, but the background very busy. So if you are engineer to development the 5G, you have to understand the code flow in the 5G part. But if you are development for the UE, for you, the message is very few. You send out your service request and then you get your user data. And then you will get your, for special, maybe you will get an IPv6. Okay. So this one is for UE request the PDU session establishment for non-roaming and the roaming with local breakout. So let's review it again. Non-roaming means you are in your home. For example, in Taiwan, you are using Chunghwa Telecom, Firestone, or Taiwan Mobile. Then you are in their home service there, not the roaming. What is roaming? For example, you go to Japan, and you are using the Firestone, so you are roaming in roaming area. Okay. So again, the UE try to get a PDU session establishment request. Here, UE get a step, and then UE send out the first uplink data to get a downlink data to get a different IP address and the blah blah blah. Okay, very simple from the UE side, but very busy in the core network side. Okay, we just know that is enough for now. Right now, we will do the exercise. So please open your notebook and please look for this one. 5G core network PDU pink. but it's okay. So I will show you how to do the analyze. The first step is 5G SA. SA means stand alone, stand alone. So here's a quick question. What is NSA stand for? Yeah, but actually, what does it mean? What is NSA?
The core is funded by 4G.
Yeah, and another one for your mobile with NSA. Actually, you are serving majorly in 4G. The 4G is major. 5G for NSA is just plus. If you need more data, you will set up another leg to 5G. But otherwise, almost all major procedure is happen in 4G for NSA. Okay, but 5G, so we talking about the standalone. So we will set up one PDU section, and you will get the default 5QI9, and you try to ping 10 seconds, and you save the enter log. Okay, so let's see the more detail. So if you have any question, please raise your hand. Don't be shy, okay? So if you open your laptop, you can try to load the data. And if you have any technical issue, I'm an engineer, just ask me. I will try to go to your seat. So you will look at this one. And please remember to put your filter. Otherwise, you'll get more and very just like a garbage information, right, for you. But if you with this one is a filter. The filter can get more detail and the specific data for you. Okay, so we put the NGAP and the GTP. Okay, so what does it mean? Remember here. Okay, here we see the GDP, right? So if you put the GDP as filter, then in your screen, in Wireshark, you will filter only GDP for you. That's between the N3. Okay. So what is NG40? Sorry, NGAP. NGAP is here, is N2. You can see the NGAP, right? NGAP is control plane. GDP is user plane. So if you set up the filter, that means you get a control plane and user plane at the same time. Yeah. And what is the stand for? It means or. So you will show the NGAP or GDP. So you put it together. So you can see the code flow. One line is one message. So you can see the initial context setup response, registration complete. Okay, I skip the some. Before that, there's still some. So registration complete, video session request, and the accept. And after that, you will see the pin reply, pin request and the reply. And here is the registration. And here is accept. And here is UE context release command and the complete. So this is the code flow. Can you show this one? I want to make sure you can. The first you install the Wireshark, and then you have the log, and you log your log, and you can display that with the correct filter. So any question? No? Good. So if you have the log in your hand and you can show it with correct filter, then I like to get a more idea for you. Okay, so you can see, you can try to see the data radio barrel. This is wrong, not dedicated. In 3G, that's dedicated, but in 5G, they change it to data radio barrel, more simple. Okay, data radio barrel. You can see the term, but actually in 5G log, there's no this term. You need to open another log like a UE log. You can see this term. So in the core network side, you'll see more. You can see the NGAP GDP tunnel. It's between here, GDP tunnel. But actually, the genome being left, you can split to control plane and user plane. So you will see the CUUP, CP, and the CUUP. But sometimes they are physically joined together, but logically they are different. CP is control plane, UP is user plane. Okay, so F1 AP and F1 U. Okay, so here is BU, and here is NGAP, and here is GDP. Okay, so I believe you can understand what you are looking for. Okay, let's go more detail about this log. Please searching for PDU session establishment request. The request is very humble. Humble. That means that UE try to set up. So he say, hey, I need it. So I send out the request to MFO. You see the detail. They including the ID and the mentioned as the N1 SM information and PDU session ID and the initial request and the DNN. Here DNN is internet DNN. But I didn't introduce DNN, right? So we need to background here, maybe here. Any DNN? No, not here. Here. Actually, DNN is here. You can image the UPF, I mentioned is a gateway, right? The N6, a lot of N6. So you can have many data network. So in the real operator, you can have many DNN data network name or data, I forget. The N6, you can have a lot of DNN. Each DNN have a special term. Actually, in your mobile, if you want to access it, you have a special like APN. APN is 4G10. DNN is 5G. So APN actually is DNN. So you need to select like a firestone.com.tw or internet. Okay. So here is the DNN. So you can check the DNN in this messaging. DNN. So if your call failed, maybe because your DNN is wrong, so you cannot get the correct access. Okay, can you follow this page to show in your log? Yeah, can you?
It just doesn't open. I cannot see all the things. I can find the SPDU, but I see it like this. See this.
Okay.
Yeah.
So yeah, you see, if you stay here is the first level, the content is like a hash code, but they will decode here the content for you. So anybody can follow this page. You can show on your screen. Don't be shy. Don't be shy. Because today we are trying to use Wireshark or Keysight Wireshark and to learning the basic skill to analyze the log. So any problem, just raise your hand, okay? I will continue. Okay, next page. We will see the same. video section establishment. Okay, so we can get a message IPv4 and the reflected QoS not support. That means the 5G, that's the establishment request. Okay, so what's the meaning? The meaning is the handset for the 5G. The handset does not support the reflective QoS, does not support. The handset does not support. Okay, so I try to translate in human language. Okay, so the UE try to talk to MF. Okay, it's my first request to you, and I want to connect the internet BNN. Okay, and please assign me as the PDU1 or PDU2. Okay, and I send you the section establishment request. And what is my maximum data rate? And I'm using IPv4 or IPv6. And what is my section management capability? Okay, so you know from the beginning, very beginning, the mobile provided information to 5G core network to understand my capability. So let's see the next page. Okay, the code block. So the PDU section resource is NGAP messaging. So you will see the AMF will try to talking to G-Node B. Okay, and this UE aggregate maximum B rate is this one. It's very huge, right? Around 1G, right? Or 10G, I didn't calculate. Okay, so you can see the UE aggregate maximum B rate. So that's what we see is AMPR. So if you remember in last week, we are talking about the AMPR. AMPR is actually here. Aggregate maximum B rate AMPR is from here. So now you can check AMPR by yourself. But don't say, oh, I didn't look at the AMPR. AMPR is this one, aggregate maximum. Okay, so next page, you will see the slicing. There's no slicing in 4G. So we can see now SDAP is unique in 5G, and also the slicing is unique in 5G. Okay, so you can see the NSSAI, SST, and the SD assigned here is in resource setup here. And again, the AMPR here, and the TLA here, and the tunnel ID here. So we can see here. Okay, now let's take a 10 minutes break here. See you later.
找出人口，那可能像现在这次状况下，关系，他们现在可以在中生， 我想我他请老师是不要这个。
也跟我是
目前他觉得就是说，在做整就是方向，或者是或者是整一直跟就是这个类型。
可是对你的题目是什么？
目前的是
因为我理解一个那个 A B 是类似的，除了 festival 之外，还有其他的东西在身上。
目前所有的当然接或者在这里少一块的数字，就是
后面有还有的是什么？
因为在安就是比较是这样，对，关于这样对。
听起来觉得太简单了。
说直接用说，
不过我猜你有 online 第一个是这是 online 像图片里面有没有光宝的？光的，就是有光宝的。我最近在那个要求一些文派是错的，所以你要试着用光口专接呢去用。还是你要用什么去？
目前的话是用自由的，基本都在做有什么是那因为这部分接下来是像书本，有可能要从那个做一些。是关注山东的有，然后上次的关注的是跟报纸文或者的整个的这个信息调出来的是它去从那个在这个去下把这个就是CPU的那方面，对，还有在那是做这个地方。
你毕业几年？你想要做这个业绩，还是你想要做？
我是要那种有点但没有打算要在
你觉得很快？因为内容学术本来有有价值，因为我的价值其实我也觉得，它是挺愿意说可能是大概心里感觉就是纯粹的只是计算的运动，因为我在这里我接到的 IQ，可是很奇怪是，我本来期待真爱还在 online， 应该是国内的一个老师。国内的一个公司叫什么？叫美国记不是谁那选的一个书，那就是那一大堆的地方，后面变成上面那个就是可以接他的这个语音之后，他可以说些有什么放那些，可以叫做 left view， 英文 left view。OK， 把你的 NSP， 我把你的 NI 可以做这样的事情，是很多，所以我觉得看起来。就是把一个更大的学习为价值的方式，就能解决类似的这个题，就解决任何东西。不可能给他去老师像现在的，也许我们吃饭的时候就有点像先到我们是吃饭的方式。好，所以你算是来帮助你，你已经修过了，谢谢你的时间。来，请坐，请坐。对，是这样。 这是一个小题，要去，因为被折起来，所以你发现没什么那个。那时候是其实我们对他没有把它讲出来，那个是靠谁出来？啊，你现在说给我，
你看我做成点温度，当然看不了冰，这冰
没有温度。
一个我操，基本上可以做到这样。
你是第一次换，那下次就会记得。
这叫我经验。哦，冰的，我应该说完全。
已经在中间。
虽然那一下，大概是应该是有这个文化，老一下。
记得那时候作业稍微简单，我常会忘记，然后这里是你没有沟通好，它第一步是 EA encryption， 这个现在举的例子，然后它就有一个加密，然后你跟他说请用这个方式去加密去解去往前，对，它是加密它这样子，然后你可以看到世界出来了。所以这一行的一定是上面只很低哦，对，所以是我原本这个报告是他没有解成。有，我这一个到现在讲一下这个，谢谢你。
但是它是我如果用还看得到，还是它没有解出来，所以
你如果没有勾它，你会发现它是 S code，它会变成 S code 存在。不然你可以把你去再看一次，它会把成回去。然后你最后变
对啊，为什么？那我不能预设它全部都给它点空？
还知道为什么有些有这个无感解释版本问题？因为我不应该会给开真的，对，所以你之前是有用过，对啊，有用过，那你有对啊，都可能是以前，
可是那你为什么不要打开？
因为你不觉得都这样子？
哦，老师的时候讲，
那都应该有程式。
我的意思说，它不能端上不能预设全部都是，因为太多就可以对啊，它会被炸裂。
没错。
有。
你说有一个这样说，这样说，因为日本的 A 对，然后那个我那边这个那个。它跟 AM 沟通，它是通过 MM 嘛？对，然后它的 MM 是塞在 RC， 在这里好，你在这边会看到 RC， 然后呢 RC 会被塞到这个NJB 里面，但是 RC 被取掉了，这个 NAS 会映射在这上面，所以你会看到你会有一个叫 uplink 的一个 NJB， 然后它就会在 NAS， 然后这边就解出来了。
哦，所以它是一样是抖音，然后就包着 RC， 对，跟 NAS 包着
RC 到这边，然后他下车以后塞到换另外一辆车叫做 NJP 过去以后又把它取出来。
对，所以这条就叫分位，他们叫
对，好，一个逻辑的一个
对，好，了解。对，
一个逻辑的一个我们开始方面就是那个
如果不要从这种
你说这样读资料的情况，那可以要这种分度，然后它可以这样子，绿色有 back，紫色对吧？在实现上的这个可以不从那个可以到那个，就是有台南是 UE 对不对？UE 想跟，因为 N 柱基本上就是肌肉的 B 跟那个 M 的连线，它可能是一条光嘛。然后，对不起，我可能不知道你在什么位置，我问你什么？
比如说在我们真的在网络的做上，可以不走不经过每个类就直接从 PC 上插到 computer。
不经过
都紫色那个没有，刚刚没有背色，没有那图没有。
你问这个，
对，它可以真的可以这样子做。
不可能。
这个如果是光的话，它一定要透过 Make 来对不对？所以我觉得这边漏画了。
它漏画了。
可是这里的 Make 会跟这里的 Make 不一样，这里纯粹就是Ethernet，我觉得它只是 Ethernet。
哦，
对。你注意到这个细节，对，没错，它漏画的 Make，
所以来讲一定要，
我觉得一定要好，一定要，它要不然就看话，不管它是光还是电，它都需要一个 Make 才能
要走到那个。
对。它漏画。
make 不一样，它的 edge 是。
因为它如果自己画 Make 的话，你可能会知道，但是那个手机跟基站之间的 Make，它有不同的结构，完全不一样的结构。然后这边 Make 是比较属于外的有线端，可是它有 Make， 对不对？我问你，我漏掉你，看得太习惯了，没有。好，这里有一个小技巧要介绍给大家哦，就是有一些同学他可能，那我先去念一下，可以看到程序的31A上这样子，然后如果你们发现你们下完指标之后，先整理一下。review 吧，然后 resize color，好，我们这样看你说的都好。有一些同学发现说，他看不到这些 uplink 的那时候，好，这边顺带说一下，我们刚刚不是有说搭车的概念嘛，就是一个 message 很像一个乘客，好，从手机如果有个 NAS，他先搭车到 RRC，sorry，OK，just like take a bus。So you are a subscriber, you have some message, so you take the RC and go through the OTA to the Gnode B, and then your message will change your bus to NGAP. So your NAS will take the bus of NGAP, go to the MF, then you can get it. So you can see here is the uplink NAS, but somebody didn't see here. So I will show you. If you have problem to look at, please follow me. You go to the editor, and then you go to the preference. Okay, so you get here, and please check the protocol and looking for the term of NAS 5GS. And NAS 5GS. NAS EPC. Where is NAS 5GS? EPS. Change the term.
I used also like the command contains in the filtering NAS underscore 5GS. And then you only display the package that has that.
You see,
So if you use this one,
yeah,
like this, contains NAS 5GS, you can filter only the packets here that have the field for NAS 5GS. Thanks, 5GS. This is what I did for the deliverable, but I'm not sure if it's correct.
but if your screen show the not green, that means your filter is not 100% correct. But you're lucky, you can get what you need to see. That's good. But I'm looking for the something like this one. Is I changed the name version. So I'm trying to looking for the else. It changed. I don't know why. Okay, so also here is different. So you look at for decode the message with the encryption A0, right? 5GS NAS, right? Algorithm and the follow conversion. What happens if I uncheck it? Let me show you. If I uncheck this one, okay? So here is okay. Then you will see all the NAS will gone, disappear. You can see here, up NAS, but it's empty. Empty. Let me remark for you. For example, this one. Right? 1988、1992、1988 this one, you can mark it. Okay. Remember it. Now it's empty, right? So again, you go to the editor and the preference. Okay, and the protocols and the 5 here 5G NAS or NAS 5G, maybe in your different version. Here, the code, please check it. And okay, and you can refresh. Now you will see the same path. Here is equal where. So please make sure you check that your side, right? But okay, so we will go back to our slide and then continue. Make sure everybody can follow my steps. Okay, So that's important about PDU section resource. PDU section resource is not a NAS. That means the PDU resource is between genome B and MF, genome B and MF. Okay, here is AMBR. And one important, again, AMBR uplink, downlink, and the slicing, and the PLA and the PID, GTPID. And the QS is our structure, right? QS is also here. Now it's default. QS flow identifier is 9. And here is ID. Okay. PDU section resource. Now we can see more about QS. Okay, so non-dynamic YQI and the allocation ARP. So the label is 8 and the non-trigger preemption. Okay. So we can check more detail in the protocol. So I try to translate to human language. Okay. So the MF to genome B. Okay. So this subscriber means this UE. So his applicant maximum bit rate and the PDU section and the slicing. Okay. The UE sent in registration, including the slicing. So the user frame, the GTP, GPS tunnel protocol, and there's one ID PLA, and the QS flow setup request, including QFI, eNotify, and 5QI9. So what is dynamic 5QI? Because we see it's not, that means there's a dynamic, right? Dynamic aside 5QI, which require a signal QS characteristic as part of QS, can be used for service standard. Packet delay project is for reserved packet delay project, dynamic 5QI. But actually, in my job, I never use the dynamic 5QI. Maybe in your lab, in the future, you will use it. But you can see the standard or spec always go far away. You can see the 2019 people talking about the dynamic 5QI, but in real, right now, I have many customers like Pegatron, like HTC, but they are not using this one. Yeah, so let's just use spec label. There's some information about preemption and PDU accept. Okay, so before that, I will talk again about the what happened here. For example, maybe if you are UE, you are genome B, and you are M, right? And the UE power on, you already registration to MF4. And the right, you need a service. So you need to request the PDU section requested to you. Okay, but remember in the real, you have a wire connection and you are radio. So you service a lot of field, a lot of subscriber in the UE, right? So you request including slicing to you, but you respect the genome B. So you have asked him, hey, can you provide the resource for him? So that's why we have that's why this one is important. Is PDU resources is important. Between you and the genome B, you have to check your resource about him because he sent a request to you, so you know what he needs, right? But you have to ask the genome B first. By this one, PDU resources. Only when genome B responds to you, everything's okay. Then you will send up a set to asset. Then you will provide service to you. Oh, remember, need to request to 5G first, and the core network check with G0B, and only the G0B say, okay, then 5G will send accept to you. Okay, so any stop, not only between, for example, if you check the core flow fail, PPU section setup failure, not only between UE and the NSU. Teleport AI, I don't know, let's see. Huawei, maybe it just updated recently because it just happened the first time. You say, okay, and he will say, I'm here, I'm here. Okay, so if you do the troubleshooting in your lab, especially registration or PDU session, not only between, you cannot only check the UE side and the MF side. Sometimes in my experience, you have to check this side. Sometimes G0B, for example, it cannot provide the slicing for UE, or the UE request the AMPR is very broadband, but because you already service many assets, so you only can provide a limited AMPR. So sometimes the PDU session resource will stop here. Then you will get the PDU session rejected by AMPR. Okay, that's some idea about the troubleshooting. So that's why it's important to understand every step about end-to-end, because every step will associate with the result. Okay, so accept that. So MF will respond to UE, okay, including the N1 and the section manager acceptor. Then he will provide the detail to UE, including the QoS rule and the PDU section type and the slicing you can use, and the QoS description also right, right, and the DMM, okay. Let's see the detail. The QoS rule also write QoS rule, okay. The QoS identifier is 9. 9 means the default. Okay, so here is the packet filter. Direction is bidirectional, means uplink and downlink. Packet filter component type, match all type. QoS rule, precedent 9, and QoS flow identifier 9, and the section the AMPR, aggregate maximum bit rate. Here is a detail. Okay. Or downlink and uplink. So what is also right QoS? I try to find a resource for you guys. The PCF should provision the also right QoS. PCF should also provide provision. So let's check where is the PCF. Yeah, PCF. And also we need to find our architecture. Unfortunately, it didn't show on this picture. PCF, I believe, is very close to the UDM. Maybe here is PCF. Didn't show on this. Here, PCF put together with SMF. So SMF. Okay, so you can image there's a one male element is PCF here, close to SMF with N7. So you need to close the region about the material quite often to understand all the information inside the protocol, inside your logger. So if you try to understand the authorized QoS, then the function is defined in PCF group. with the detail. Also like QoS. Yeah, again, just like Ian mentioned, if you didn't pay, then PCF will say, oh, the subscriber just can use it before. So the only authorized QoS is before 9 or 7. Okay, another one in the acceptor, you can see the slicing in more detail. Sometimes you will see the slicing the SD 1981 and the 53. But if you check in your calculator, you will see this one actually is 030609. 030609. This one is for SD. This one is quite often in my customer. They like to use this one. It's very easy to remember how 030609. But if you change it to the PEC, then you will get this number. It's this one. Actually, it's same 030609 for SD. Okay, but it's the E and PP SSD is one, and the SD is here. And then there's the main EPS. EPS means 4G, EPS barrel, and here is internet. Okay, there's another point to mention. How this one is more authorized QoS, EPS, and the PDU identifier. Okay, so now is the MF UE. So I accept your request, and I will give you what you can use the QoS. Okay, so and also how many bandwidths you can use, and I will assign the IP address to you, and I will allow the slicing what you can use the network slicing, and which DNF assigned to you. And I will send the QoS description, including the flow IP and the barrel ID to you, and also a PDU session ID like you requested. So this one is important, and remember this one is important. Until this one, the UE to get IP from the network, and then all your service is based on this IP. So if you are doing in your lab, remember, only in this step, you will get the IP address. This one is used for all user plan. Okay, so PDU section with response, RSP response. Response is the tunnel ID and the TLA and the QoS flow. Okay, remember UE, GNOB, and the element, right? UE requested you, and you talking about here, and he said, okay, it's this one. PDU session resource, okay. And what is okay is he assigned the QoS associated with the tunnel. Here is the tunnel. TLA and ID, because he need the resource between GNOB and the UPF. So you can see there's another people here. So you are MF, here is UPF. You are GNOB and U. Again, he need a resource to you. You check with him. And he said, okay, but actually he set up a tunnel to here. And the tunnel, including the QoS and the ID. And after that, you will disconnect with me, and every user plan goes through like this way. Yeah. Okay. So very beautiful, right? You talk to him, auto plan, and then you set up user plan here, and after that you go through everything here. Okay, translate. So GNOB to MF will say, okay, I'm okay with your assignment. So I will provide a tunnel to you with the UPF. Okay, can you open another one, UE site? If you can, please follow mine here. So we have more complicated filter here. Actually, you can just copy it, or I remember I provide it to Ian, but I'm not sure if he shared to you guys. I don't like display mode. Okay, I'm not sure if you have something like this one. Yeah, because this one is my experience. I use the Keysight Wireshark doing log. So how do you use it? For example, you want to use the filter like to show the there's more detail. This one to show the RC, NAS, and the PIN and the UDG with the CRC error. On this one with RC setup complete, you just copy this one, copy and paste in your Keysight Wireshark, the first line. And remember, only when you show the green, then you can display it in correct way. Let me show you. But I want to make sure if you got this one, you have, right?
Yeah, it's okay.
Okay, so you can do it. Please follow me. So what's the major difference? If you check the tool and then you see the Keysight Wireshark configuration editor, that means this one is Keysight Wireshark, not a normal Wireshark. So you can open the file. Okay, please don't use the reg only, because reg only, the means only show the message 1 to message 5. Please use this one. And ERSU file with the pin complete and open it. You will see a lot of information, right? So in my site, I just click on this one. You can create your shortcut. This one, I believe you are empty because this is shortcut for filter. And here is a very simple one, like to show the NAS 5GS or NRRC and LSU number 1 and ICMP, and you will get the major information you want to look at. Okay, from the RC setup to the security mode to UE capability and then to the pin. And after that, you can do the label. Let me show you how to do. For example, you already copy and paste the correct filter and to show the information. Then you can hear, and you can give a name. NTUST. NTUST. Okay. And remember to click on OK. Then you will see here. I just knew the new one is here. So if you click on here, it will display this information. Let's try one. So copy and paste the filter and give a name of yourself. You can see here. I can show a lot of. For example, I show the message 1 to 5. Okay. Here's only 1 to 5. And I show the filter with the label NTUSD here. Okay, please make sure you can follow me to open the PSI Wireshark, and then you know how to copy and paste the correct filter you need, and to save the label. And later you can click on the label to get the correct filter to show the detail. I can wait here until everybody is saying okay. If you are using the Apple, maybe you need to connect to another computer, right? I want to double check. Can you install it with simulator? Oh, remote access. Yeah, any limitation. So everybody can remote access.
Yeah, so personal PC.
Yeah.
This personal PC. And remote on my personal PC.
Oh, your personal. Yeah, that's cool. So make sure. Can you show that? Let me check. Because
Yeah, this one is not fine on the GitHub.
okay.
That's how it is used by my color, like green.
Yeah, the green, only green means the syntax is correct. No, it's,现在下面是你是不是 ？RC 那是 pin， 我觉得你扣这个是什么？那是我加的，对，你可以按右键然后去用，但至少我下完右键都可以有，所以其实是一样的。OK， please don't care about the color because I want to make the color by myself, but the color didn't change by the filter. The filter only limited what you're looking at, but the color about the pin or about the nuts is another way to define. So the green or the pink, don't worry. You just use a filter to get the information. Okay, just skip the color. So everybody can show this picture.对，有点不太一样。绿色是按右键，它有个 frequency， 我没给它的，可以给它是不同的 color， 或者是按那种。对， 好像有一个 editor 在 difference 在那，下次可以给他的 editor，例如 editor，然后 difference 那边就是他的，那是有单的那个图片，然后这边也可以给，但因为它比较慢，它跟分析比较不一样，但是比较分析，所以你可以给不同的就包括那个，比如说 RC 一个颜色，那什么的色，就是我看到那个你可以选择什么。对对，它可以改变你的概要，或是哪个颜色，甚至改变图的颜色，可以用这个颜色过来，比如不满的可以放改。对，再试试看有没有。你说，应该是它。就是好，那边呢，然后这个是出来一个，然后这个是下去，然后很多美化那个，这样是这个意思。对，所以可以装它的出来。那个什么，就你之前给我装，那你不能在旁边装，你要打开那个，因为我们有两套，你刚刚那个是必须用标准的把它上出来，你这个是哎是那边可能不同的洞，这边用不同的套，这是叫做换，那一点那个必须的要求。你下面咱们那个。Okay, so any question? Good, good. So let's go back to slide first. So we have filter, and we have the RC message and the NAS messaging, and we have user prime messaging, and we bid registration and the RC release. There's a conflict control in UE side. Okay, let's go to detail RC reconfiguration. Okay, so I believe the message 1 to 5 is already very familiar because there's a Professor Chen, he's an expert for the access, random access part. So after that, after registration complete, the most important is the RC reconfiguration. And you will see, hey, the NAS with RC is joined together, right? Because remember, the RC take the nuts, take the bus of RC. So of course you can see the nuts inside the RC. They are together. So RC reconfiguration here, and you can see the BRB ID here. BRB is here. BRB, you can see the BRB here. So that means in real life, totally the 3 RC reconfiguration. RC reconfiguration 1 for default QoS 9, or most is 9 or 7. And then he try the mobile, notice you try to set up VONR. So you will get another 2 RC reconfiguration. 2 for INS protocol, and 3 for RTP protocol. Okay. So you will see here, it's NAS. Okay, translate. The G0B to UE, he will say the map QoS followed after, and then QoS for ID. RC reconfiguration is a downlink from G0B to UE, SDAP, and the QoS pro here. BRB to other. Okay, so downlink. Yes. Remember here, okay. Here or BN data network, right? There's a lot of user brand data here, like YouTube, like Facebook, like WeChat, like X. And go to UPF. UPF is important. Inside UPF, the function to make every user brand based on IP flow with a tag, with a filter, SPF, and go to the big tunnel of PDU section with the tag of SPF. For example, SPF 1 and 2 into this small tunnel in big tunnel. And there are 2 SPF 3 into this tunnel, and SPF 4 into this tunnel. And here with the QoS label, different. Here, there is no QoS here. Here is SPF, but here with QoS. The QoS means the priority, means you go first, maybe means that your bandwidth is guaranteed or not guaranteed here. Okay, QoS flow, non-guaranteed, and this 2 is guaranteed. And here is SEAP is important. And here is the radio barrel 1, 2, 3, and to UE. Okay, so end-to-end view. You can see there's a normal internet, and go to the 5G, you get a filter label, and you got the QoS label, and you got the radio barrel error, and UE finally get it. And back to the service user bank. Okay, this for downlink. Now the table will show you the second time. Example of guarantee period. So if you look at the 5QI 1, 2, 3, 4, and then jump to 65, 66, and then 67, they are all guarantee period. And with the different priority label and the packet delay and the packet error tolerance. So you can see this one is best because the tolerance is the minimum. And about the average time window, And this one used for non-compensation is for buffer video streaming. This one, I think it's for high quality. And for VONR, VONR 1 is for this one. It's for RTP. So you can see here is for conversation voice. So this table is important if you are an engineer in the future for 5G. You need to check the QoS table, this one, for different application with different parameters with the guaranteed rate. And next is for non-guaranteed rate. The typical one is 9. That's for most often for default. And this one is for default, 9 or 7 for default. And this one is also. So 7, 8, 9 is quite often you can see used for default QoS. You can see the video, TCP-based email, chatting, like a lot of non-guaranteed rate. And here is the layer parameter inside. I think there's also very good quality because the packet error rate is also limited. This is very small. Another view around the control plane, handset, G0 B, AMF, SMF. And this one is wire, this one is radio. Radio important is RC and the data radio payload. And this one is the NGAP. NGAP is important for PDU section setup request. Why is a transfer? Transfer means the PDU section setup is between UE and the NFO. For G0 B, he just like a bus. He is the transfer. And this one is a NAS. So this one is the transfer. And the QoS flow setup request is the QoS flow ID. P5 means the 5G. 5 means the 5G. 5G QoI. And the NGAP successful outcome messaging. PDU sessions response also transfer. Here accept, here request, here accept. Okay. Here also mention section resource setup. Resource is between them. Resource is between them. So you can see the setup transfer and the setup response without fail application. Okay. SNF. Yeah, I will tell you more detail. You will see, hey, it's very strange because you say the user plane is set up by control plane, but user plane is go to the, okay, I will show here is UPF. UE G0 BMF, right? He tried to set up with you, but how can you communicate with UPF? No, there's no direction way. So there's the SMF. You here and you thinking about SMF and SMF here. So this one is important. UE try to set up the PDU here, and he used the HTTP talk to the SMF, and SMF talk to. I remember this one maybe M4. Let's check the slide. Ah, yes, M4. So you will see they are very, very detailed. If you UE request to you, but actually you talk to SFF. So SFF is important because he's between AMF and UPF to coordinate everything. So that's why you set up the tunnel with you. Then you will tell SMF the tunnel, and the tunnel will assign to UPF. UPF will set up the really big tunnel with you. Actually, it's the N3. You talk with M is with through the N2, but the pipe is set up in N3. Is here. Yeah, so it's very complicated. But remember, when you are go deep in 5G whole network, you already understand something about it. Okay.
Why they use HTTP in this case and not other protocols?
I don't know. HTTP too, right? Yeah. I don't know why. Actually, here you can see like N3. No, not here. It's here. So you can check the 3GPP with the N11, you will get a spec. And maybe you can find, but I don't know why you using HTTP2. Good question. Okay, so now we go to the range side. The range side is a mapping between the user plan in U handset with the G node P. So you will use the SBAP. Okay. And you can check the clip from YouTube to study more. So the important page, you can see this is core site. So we already set up the PDU section. So we got a flow buffer here, and then we get a QoS flow inside. So the service radio level 1 and the 2, and down to the PDCP, and down to the RUC, down to the MAC, down to the physical layer, down to R. Obviously, just like this one, maybe. So you can see the SDF is very important. Sorry, SBAP. SBAP is very important. Need to distribute the different QoS flow into the real radio protocol stack. So the SBAP. PIN. Let's talking about more about the PIN. The PIN have the source address and the destination address, and the TID and the QoS flow is the QoS flow. So you can check this slide, the end-to-end from UE, the upside is 4G and the downside is 5G. You can see 5G is more elegant, beautiful, right? And more simple, more efficiency. And for the 4G, just like this way. So here's a comparison. Another table to compare 5G and the 4G. Okay, you can see the different type. The QoS flow, EPC barrel, QFI is the enhanced barrel ID, and RQI there's no. So this one is unique in 5G. And data section in 5G is PDU section, in 4G is PDN connection. Okay, again, and then I think we already familiar with this one. Familiar. Yeah. Uplink. I like this one. The code flow is more simple, right? So at the first, the GNLB continue broadcast MIB SIP1, MIB SIP1, right? So the UE, when you power on, you will search for your surrounding, and then you're looking for the stronger one, and you try to decode the MIB and then search for SIP1. And you can send your preamble to the target GNLB, and target GNLB will send a message to you, and then you can set up the RC setup request, RC setup complete, including the registration, the first initial registration, and here, and sometimes the 5G will challenge you, who are you? So you need to do the identity, okay? But it's option, it's not mandatory. Sometimes you will not see that. And then to do the authentication request, security mode. And this one is important. You will see the does anybody notice UE try to do the registration twice? That's important. It didn't show on this slide. I will show you. Real log. Okay. Please follow me. This from the UE side, you can see the message 1 to 5 until RC setup complete, and the authentication request is a dynamic NAS from 5GC, and after that, you will send out the registration request. So you see once, and what's the difference? The first registration is here. Okay, the first registration, you will see the registration is more simple. The UE just sending the who am I? So he will send his MSI, his short IMSI, short subscriber ID, and also the UE provide his security capability. That's all. Okay, the first registration. And after the authentication and the security mode to protect the NAS, then the UE will send a second time registration. This one including more information. Let's check it. Okay, especially UE sending the slicing information in the second time registration, and the more network capability information. That's the difference. Okay. So actually, UE will send the registration twice. And after that, the GNLB will ask, what's your capability? And the UE will reply the capability information to GNLB. And GNLB will forward the radio capability information and the core network capability to MF. And here, the GNLB will do another security. Actually, that's wrong. This one, because the capability is information, this procedure should be here before the capability inquiry. Okay, it's minor, so it's okay. So after that, the RC reconfiguration standard with the SDRB1 for default QoS, and the UE will reply RC reconfiguration complete. Okay, so the GNOT-B will set up the content setup response to MF, because here is the initial content setup request and the registration complete. So until now, the registration complete here. This is a NAS, so the forward registration here. And after that, UE need a service. So the PTU section establishment request here, and then accepted here. But remember, in the core network side, it's very busy to check everything. Okay, more than this one. So I would like to summarize the whole procedure again to you. Again, UE, GNOT-B, MN, right? So GNOT-B, you are very busy. You're sending out the MIP and SIP1 all the time. Anybody know what's the periodical about the MIP1? How often? Anybody know? How?
Maybe 5 milliseconds, 10 milliseconds, 10, 15 milliseconds.
I remember usually it's 20 minutes. So you are very busy. You broadcast the MIP, SIP1, MIP, SIP1 each 20 milliseconds. So you power on. So when you power on, you are searching for your surrounding, and you catch your MIP1 with very strong signal. So he tried to send out the preamble to you, and then you reply the IR to handset. So you set up RC setup request, you set the setup, and the setup complete with the first registration to you. And you want to challenge him, so you do the authentication to you, and you authentication response to you. You need to protect your NAS, so you send the security mode command to UE security mode complete to you. So your NAS is protected. But at the same time, you ask who are you? What's your capability? So before that, you set up the security mode between you and that's over the air, that's RC. So use security mode command complete, and then you ask UE capability. What's your capability? So you provide your capability to you, and you forward to him. That's important, because if you are very old piece handset, and they are very new, and your capability is very low, maybe they cannot provide to you. Or if you are very new, but you and the MF, the function is limited, so maybe your capability, but they only can provide limited service to you. So to check the UE capability, very important. Okay, so after that, you already set up the NGAB tunnel with the initial content setup requested. And after that, you will request the PTU section for you. And then you will ask the resource. And then if he said, okay, please prefer the resource to here. So you send the information to SMF. SMF also forward to UPF to check everything. So your big pipe PTU section here is you radio. So you have the data radio barrel, and here is GPP tunnel. So not everything is okay. You can get the service to DLN. Okay, it's very simple code flow. I hope you remember, keep your mind. Okay, so we have information about quiz. we have 5 questions about the basic the term, the QoS parameter, and 5 questions about basic definition and the explanation about QoS parameter. I added 2 questions for bonus, but I think that it depends on you. You can only select the 10 of them by yourself. I provide the 12, but up to you. You can select only 10 for easy to calculate. Okay, so yeah, all information is included in my slide, so don't panic. So now I will go to maybe homework. Yeah, let's try to do the homework. Homework. And by the way, I have a dream. If you can develop an AI to analyze the PCAP automatically, for example, you just input the PCAP, then the AI can go through every detail. Then he can answer the question to you. For example, the Wireshark I provide to you, there's only 1 subscriber, right? But even only 1, if you compare the end-to-end, you will see, there's a detail. How can you imagine if there are 1,000 subscribers inside the PCAP? How can you distinguish who is working for what, right? So we need AI. They can portray to every subscriber the behavior, and they can answer which one is best QoS and which one has some code drop. And then the AI can answer what's the reason he code drop for what the root cause. That's my dream. Because so far I do it by myself, by human eye, and by smart filter. So I need to put the correct filter to find a subscriber. And I need to read a lot of 3PP spec to understand which root cause. And why the code drop here, I need to understand. But I hope you can develop the AI to read the PCAP and can tell more root cause for you, for me. Because there's a lot of engineers that don't like to read the log, even for the Nokia or Ericsson, they don't like. So, yeah, I enjoy the log a lot. So let's go to the homework 1. Homework 1 is to install the PCI Wireshark. You did it, I know. The normal Wireshark, you did it. And to open the .lsu for Keysight Wireshark and the .pcap for normal Wireshark. Okay. And the homework 2, the log 2022 and April 11. This is for our PPT. Okay, you already know it. So about the UE log, the basic question is what is the PLMN? That's important because we go to here. You are handset, so you insert the IMSI card. So the IMSI card including the PLMN and your subscriber ID, and you are GNOME, you also have PLMN inside you. Yeah. So let's try to look for the cell PLMN. Please open the UE log via the Keysight Wireshark. Okay, so now we have to remove the filter first. Otherwise, you cannot see the MIP and SIP1. Now you can see the MIP and SIP1 after you remove all filter. So if you click on the SIP1, you will see the content of SIP1. You can right click to expand subtree And you will see the field again here again. And you will see is 00101. That's quite open. That's quite common in lab. 00101. Can you do that? To check the simple one. So it's easy for homework one. Okay. I hope you guys can follow me. Okay. If you have any question, just raise your hand. So the second, I need to know what's your band. That's important because currently we are quite often is this one, band 70, 78 or band 79. Right? What's band in your lab? Which one? This one, right? Okay, so you can check this log. How to find the band? And you have to show a way to answer it. Okay, so let's do it. Not in simple one. So I need you to so the band. RC setup. I believe there are many ways. So if you can find the band, correct the band in different way, it should be okay. But please double check to make sure you are right. Not in RC setup. Here, frequency band increasing. Enter. Unit capability. Now, that's one way. Okay, this is one way. I will not say that's the only way, but there's a one way. The one way is to looking for the genome B tell UE to ask what is your capability. But remember, the UE, because the UE is more powerful right now. So the UE capability is very huge, very long content. So sometimes the genome B will only ask the question very narrow down. For example, in this case, he just asked for using the UE capability inquiry and only for pen 79. That means you don't need to tell me how much capability you can support for other bank. I just want to know, can you support bank 79? So that's one way to get it. So you can answer my homework here. And I will show you one snippet. Can you display this pen onto the top? Do you know how to do that? I believe if you are Wireshark expert, you know it. But anyway, I would like to show you here. Right click to add as a color. If you want to show the pen on the as one of color, you just right click it and add it as a color. Then you will get it here. And you will check it here. It's more easy. Pen, right? So you can see it's very easy. And then this handset, this mobile, actually it can support a lot of pen. Yeah. It can support the pen list that is here. But actually the Gino B just asked for 79. That's the question. And this is the answer. And let's continue to draw down to see if there are any other no. That's all. Okay. So that's one tip. You can show the pen and R. Pen and R, I believe is here. Here is pen and R. Pen and R. I believe there's another, it's like a frequency band indicator and just like here, frequency band indicator and but for some reason it didn't show anything in this log. Here also, no, it's a band and it's duplicate, so I remove it, one of it. Here, but it's empty. Okay, I don't know why. So I answer my question about the gene of the big band. Okay, the third, how to check the gene of the cell pair or not pair? Do you have any idea what is the pair or not pair? Okay, that means again you are genome big, but sometimes you are more functional. You cannot provide the service. So in your MIP, remember you broadcast the MIP. Your MIP have to indicate you in service or not in service. So you are using a cell bar or not bar. So let's check the MIP. I will show you. So please open the UE log again. And then remove all filter. Then you can check the okay. Sometimes if your layout is gone, it's easy. You just remove one of them, then you will get more easy. I don't know why. Okay, so you open the MIP, and then you can see here. It's very short, right? For MIP. Here is indicator for here. It's not bar. Not bar means you are in service, but if here show bar, then UE is not allowed to access to this cell. Okay. So now we finish the homework. This one. Okay, bar or not bar. The item 4, what is the MSIN? The MSIN, I remember it is in registration. It makes sense, right? You want to do the registration, so you have to tell the corner who you are. So let's check the registration request. And this is a 5G mobile identity inside, right? You can see here, MSIN. So we got an answer, MSIN. The next one, what is the registration type and the FOR? FOR means the follow-on requested. We also need registration. Here is the registration, right? So you can see this is the initial none here. Initial registration, right? And FOR means the FOR, pending. Follow-on registration pending. What is meaning? The meaning is you try to do the registration to AMFO. And after your registration, you have service to request them. Then you just say, hey, after registration, please don't stop me. I have continued service to request them. In this case, follow-on request pending. What is follow-on? Non-follow-on request pending. That means you only do the registration only, but there's no service after that. Okay, there's two scenarios. One is service after that. Another one is there's no service after that. Okay, where is the DNN? Please show the way to answer it. Internet. I think it's better. It's time for you guys to show. It's better than me to show. So this one, who can show the DNN? What is the DNN? Please come here to show with my laptop. You can both show in 5G log and the UE because this is in NAS. Please come to show. Raise your hand. How to identify the DNN, the name of DNN? Anybody want to show here?
By now.
Please come here. Which one you want open?
Wait, I need to see my notes.
Of course. UE or 5G?
I use in the
Core.
I think you
UE long? Or you already have the homework?
yeah, because deadline is today. Otherwise, I don't have time.
Sure.
You
UE long. So I'll open for you. Yeah, please. Now we are trying to looking for the DNN in our log.
on this one.
I think you are correct. You already got it. No. Yeah,
Here.
internet. Right? Thank you. Thank you very much. So the the DNN name, actually you already configured in your mobile. So when your mobile try to send out for service, he will request the AMF, try to, okay, so now we can add more information here. Assume we have two DNN. This is DNN1, and this is internet. And this is DNN2. It's for VLAN. So your mobile only support for data, no VLAN. So you send the internet. So the internet MF will go to SMF. SMF will go to UPF. UPF have an idea about this story. So we will try to set up this one. The pipe will go to here. And finish the panel. Okay. Next, how to check the SCC mode. Okay, please come to show. Yeah, please. SCC mode. Where is SCC mode? Come, please. Anyone like to try? To show us how to find the SCC mode. Actually, I want to say something about it. You don't need to be expert. You don't need to know anything in this homework. It's just like you try to find a term in the log, right? It's just like a game. Actually, maybe I don't know what is SCC mode 1, 2, 3, but I know where it is in our log. That's important. Actually, for AI, maybe they don't know anything, but he's very quick in searching for anything for you. That's why we need AI. So anyone like to show the SCC mode 1? How to identify it in which message, which I miss information element. Okay, now I will do it by myself. I remember maybe it is in registration request, I guess. So I will show maybe from 5G log. Okay, the first I need a filter, so I will look at NGAP only, and maybe it is in the registration request. Registration request here. So expand the structure. So you can see here. 5G mobile messaging. Follow up. Answer code here. UI security. Slicer. So this is for the second time. Never slice the user. Okay, so not from UI side, they are not. So maybe the registration request. Registration. Registration complete registration accepted. Routine. Registration result. Result. On PTU section request, nothing in registration, so I will check the PTU section establishment request. If you find person like me, please raise your hand. STC mode. How to find it? Oh, I do. This is once. Ah.
This is the core doc. I use the UV.
Oh, really?
Yeah.
Okay. You remember. Yeah, it's green. That means it's correct. Video, it's accept. It's done link. So the core network, yeah, thank you. Thank you very much. The first one, how can you learn the filter?
First I search by myself and then I copy it here.
Yeah, sure.
Right click, copy as well.
Okay, thank you very much. Okay, so the SSC mode is reply from core network. Yeah, so you also can use the filter I never use it by myself. It's NAS underscore 5GS dot SSC underscore model 1. Here.
In fact, this one there, this is SSA. I think if you need to go a bit upwards. It's on the second page, IE. Yeah, there's it. SSC mode, yeah.
Yeah, and you also can find as a column. So let's check the result. Yeah, you can see that. Okay, thank you very much. I learned from you. Okay, next question. What is the PDU address? That's important. So after PDU section, if it's complete, then your handset will get the IP address. Anyone like to try? You can find address in both UE log and the 5G log common worker. Anyone like to try? Come on, I believe you already finished the homework, right? I want to show you. It's more easy because it's also in the complete. Let me show you. Here, you can see, I can show you in the 5G. Because my way, I remember the logic. So I know the corner worker reply to handset with the PU acceptor. So I'm looking for from the accept is here. Is one of the mass. One of the mass. Where is the mass? Here is the NAS. The NAS is about the accept, right? So you can get the PDU here. Address is this one. Okay. So what is 5QI for this section? Please show a way to get answer. I believe is also in the same. Yeah, curious information. With more parameter here. Okay. The next one is here. What is the network slicing in UE? In UE, that means the UE, the registration request. So let's show in the second registration. Here is the second registration here. So you can get the slicing data here. Network slicing. It's easy, right? If you remember the logic, what is the AMPR and what is how many ICMP messages miss the reply. I leave this one for you to find. It's easy, not so complicated. Actually, in my PowerPoint, I show you many times how many ICMP miss reply. We can post in the here. So I need the ICMP here. So how to check that? It's easy, right? Because ICMP already will show you in this case, all ICMP is reply. All because it's reply. Why I say the less? Let me check. 0, 2, 3, 4, 5. Oh, the 1 is missing. Totally missing. I don't know why. No request, no reply. So let me double check the UE side. That's why you need to check the end-to-end side. Otherwise, something logical is disconnected. So let's check the UE side. And also with the pin. We only check the pin for the homework. I see the pin. Here. If you see this one, you can see there's a sequence number 001 2 2 3 3 4 4 5 5, right? Actually, I sent in 10 times, so you can see the 10. It's okay, but there's one no response, other is response. But if you compare the 5G side, you check the sequence number, there's no one. That means the packaging pin 1 request is missing. So you have to check it because there's a bigger package loss. Okay, that's one way to show the troubleshooting. I think my section for today is finished here. If you have any question, I will not leave our line group. So you can continue if you have any question or any feedback. You can personally to me, or you can post our group online. And thank you for your time for today. Thank you. Thank you.
Okay. Thank you for your time and see you next time.